Everyone, and welcome to today's Energy Storage News webinar with TWAICE on lessons learned from the first-time operation of battery energy storage system assets and how analytics can ease the pain points. My name's Andy Colthorpe. I'm the editor of Energy Storage News and Deputy Editor-in-Chief for Publishing at Solar Media. In 2024, Europe and the US deployed around 12 gigawatts of new energy storage capacity each, marking the first time that both markets surpassed 10 gigawatts of installations within the space of a year. That was split between the behind the meter and front of the meter market segments. And while the market dynamics vary, with Europe still deploying a much higher proportion of residential systems than the US did, for example, the headline numbers representing an aggressive growth phase do not lie. While 2025 has been a year in which many assumptions over the pace of global energy transition have perhaps had to be reconsidered, making it hard to predict exactly how the numbers at the end of this year will add up, energy storage is on an upward growth trajectory that constantly expands into new markets and puts assets in the hands of new owners. Even within those relatively mature markets of Europe and the US, the level of experience already gained with energy storage technologies varies greatly. New entrants join already hot markets in California, Texas, or the UK, for example, and new opportunities warm up in places like Italy, Poland, or the Midwest US, where even experienced BESS operators will face new market rules and grid codes. So today's webinar presentation tells an interesting story. The excitement, the creativity, the intense concentration, hard work, and homework that Latin American and Caribbean energy company InterEnergy went through in designing, procuring, building, commissioning, and operating its first battery storage asset of many. We'll also hear how cloud-based battery data analytics specialist TWAICE supported InterEnergy on that sometimes tricky journey, and the role analytics will play in the full life cycle of BESS projects will also come into focus. Today's speakers are Laura Perez, Operations Manager at InterEnergy, and Matt Drazenovich, Senior BESS Engineer at TWAICE. An audience Q&A session will follow their presentation, so please do put your questions for Laura and Matt into the questions tab on the right side of your screen. We won't be able to tackle all of those questions in the time we have today for the live broadcast, but please rest assured, TWAICE will be delighted to follow up and respond in full and continue those discussions offline. And finally from me, this session is being recorded and will be available in a few working days on the on-demand webinars section of the ESN website, along with the presentation slides. So with that, and without further ado, it's my pleasure to hand you over to our first speaker. Over to you, Matt.
Hey, everyone. Thanks for the introduction, Andy. Yeah, we're going to be getting into a project that Laura and I both worked on together. Just a bit more of an introduction on us. So my name is Matthew Drazenovich. I span the role of solution engineering and customer success here at TWAICE, involved in a lot of the onboarding of new systems to our platform. I've been in the battery industry about 10 years, in and out of grid storage. And hand it over to Laura to quickly introduce herself.
Thank you, Matt. Hi, everyone. I'm Laura Perez. I'm an engineer, and I have a technical background working on solar PV projects, and including the battery projects for the last 3 years in multiple countries in the region. And now I'm overseeing the operation and performance of these assets, and from here, the collaboration with TWAICE.
Thanks, Laura. In terms of what we'll be discussing today, so Laura's going to take us through a bit of the project background of FE3 and some of the commissioning challenges they faced early on, and get into some of the lessons that were learned through those challenges. Then we'll both be getting into how and why analytics was brought on board to the project and some of the issues and we uncovered during that, and how they were solved using analytics. And then, as Andy mentioned, we'll be opening up to Q&A at the end. Really quickly on TWAICE. TWAICE is a Munich-based, Munich-headquartered analytics company offering a variety of BESS analytic solutions via our platform and professional service offerings. While most of our team sits in Munich, we do have a growing team in the United States, serving North America, serving both Americas. Yeah, and our client list is growing in both areas of the world, a number of utility scale projects. And with that, I'll hand it over to Laura to introduce the project.
Okay. First, I would like to share the context of this project. CEPEM stands for Consorcio Energético Punta Cana Macao, and it's an independent utility located in Punta Cana in the Dominican Republic. CEPEM supplies energy to the hotel area. So if you have stayed there, we have supplied energy to you. CEPEM Zero is the initiative to transition CEPEM into carbon neutrality within the next decade. And to achieve this goal, we have defined a roadmap with different phases. As you can see here, we have 3 phases. The first one includes the integration of solar PV projects along with storage solutions. And at the end of this year, 2025, we will have installed 215 megawatt of solar PV and 115 megawatt, 149 megawatt hours of battery storage systems. The following phases will include wind, PV, and more storage. We are also studying other technologies in case they are feasible, but with current best prices, that's the best solution for storage right now. Here you can also see a picture of a Victory project. This is the first one of CEPEM Zero, the first one of our collaboration with TWAICE. It's a PV project with batteries coupled in AC. And here I also want to explain a little bit more the importance of batteries in this system that are needed to maintain reliability and stability in the system with high penetration of renewables. Since the PEM is a small grid, we cannot operate only with renewables. And that's why all these functionalities that we have listed here are required. So in the following slides, I will highlight some key aspects to consider related to these functionalities. Here, I want just to introduce a little bit the timing and giving you a brief overview since the COD. COD was obtained in January 2024. And in the first half of 2024, we were refining the firmware and doing tests together with our SCADA provider, the manufacturer, and CEPEM. And in parallel, we started working with TWAICE. It took a few months to complete the integration and prepare the commissioning report that was finally done in Q3. And right now, we are working in including new projects. Okay, now I want to focus, I think, in the most interesting part, that is the lessons learned and challenge we faced. It's important to say that some of them happened because it was our first BESS project, and we have been able to improve a lot in the following contracts and installation. But anyway, I think it's very interesting to share since everyone's facing it. First of all, and the most important one, and I think the one that has more impact in the operation, is the grid code. CEPEM has its own grid code since it's a utility and had to establish a new chapter fully dedicated to batteries. Some crucial specifications were missed, and it was not because they were not included, but because they were not enough detail. So when we started operating, we knew that we had to do more changes. So this resulted on delays in having the system fully operative, since we had to update the firmware and work a lot on testing. And again, since the PEM is a small grid and has a lot of PV and BESS projects distributed, this was crucial for the proper operation of the grid. Also, and this is a little bit in general and related to what Andy was explaining in the introduction, we found that there's a poor knowledge of technology in general in the market. We are still learning, and we have still a long way to go. And for example, as a fun fact, here you can see the initial layout on top of the slide. And that was the first one we worked with, and under the image, you can see the final layout with a real image of the project, so you can see all the work done there and all the improvements. Also, I would like to say that there are a lot of manufacturers now of batteries in the market, but not all of them offer an integrated solution, including all BCS, transformer, or even EMS. And for us, it was really important. And every time more manufacturers are giving you full solution, but I think it's really key for solving all the problems or the issues that can arise. And following with the challenges, and now with the operations and maintenance, we are a company used to operate motors and turbines. And with the new PV projects, we had to redefine internal procedures for BESS dispatching, to adapt the operation of the grid. And for example, for the central dispatch, the first concern was the intermittency on the generation caused by solar resource. You can see here in the image that we have solved that with PV firming capabilities with BESS. And related to this, and for having all the functionalities operating properly, the configuration of the SCADA and PPC is key. And also highlight that for a system like FEPEM, that it's a grid and has several distributed projects, it's also very important to have a global energy management system. And we are currently working on having a full solution. And above that, with TWAICE, that as Matt was saying in the introduction, it's an analytics software. We have been able to track batteries KPIs, since without TWAICE, we still didn't have that implemented with our SCADA, and also warranties. So we have been able to see more in depth into the batteries thanks to TWAICE. So I will leave you with a short poll before Matt gives you more details of the TWAICE analytics software.
Thank you very much, Laura. That's a great beginning to the story, really, I guess. And I wonder, how many people watching can relate to a lot of the things that you're talking about and have gone through similar learning curves, whether previously or they're doing that now. And we've already had the first few questions coming in from the audience, which is terrific to see. So please keep those coming in. We'll try and tackle as many as we can at the end. In the meantime, you should have a poll come up on the screen for you. So yeah, talking about some of these challenges, which of the following are your top challenges? And your options are system performance and availability, which could include things like cell or module imbalancing, data management and integration, degradation and lifespan management, so planning for the later life of the project, and how aggressively you're going to use it. On a related note, I guess, warranty and contract management. You could have found that safety and risk were your biggest challenges. Could have been coordination with operations and maintenance teams, or it could be something else. So yeah, so I wonder, Matt, what do you think? What would your prediction be, do you think, as an analytics person looking at this?
Well, we come in with, while projects are usually being commissioned, so we're seeing, oftentimes various types of delays. It seems to oftentimes be integration issues, whether that's getting the control strategy sorted out for the system, and then trying to debug issues with control strategy versus equipment, that sort of thing.
How about you, Laura? What would you expect the audience to say? And then if you can tell us which was your particular, which would you have put?
Yeah, I think the audience will be worried for the topics that we were at the beginning, that it was the performance mainly of the project and everything related to warranty. So let's see the results.
Okay, and let's do that. So just watching the results come in, and everyone's responded pretty quickly. So I think we've got a decent sample size from the votes that have gone in. So thank you so much to everyone. So many of you participating. I think about 80% of people logged in have responded. So drum roll, please, as they say. Yep, both yours and Matt's predictions, Laura, were the top two. And if it was a competition, Laura, you've won ever so slightly. So 26% of the audience responding said system performance and availability, but no shame, and Matt's coming second there with 19%, so just 7% behind data management and integration. So it's worth noting that all of the other responses did have, significant percentages of respondents voting for them, but the data management and integration second, and system performance and availability won out as top challenges over degradation, lifespan management, warranty and contract management, safety and risk, O&M coordination, and the nebulous other. So there we have it. Don't know what conclusions you might be able to draw to then feed into the rest of your presentation, Matt, but I hand it over to you to take it away.
Thanks, Andy. Yeah, I mean, the system performance and specifically what we offer with our performance manager module is very in line with optimizing availability and that sort of thing. So no surprise there. Yeah, the sorting out data issues early on is always seen as a challenge. But yeah, let's get into a bit of why BESS analytics is useful. Why InterEnergy decided to go with this, and where does it kind of fit into the technology stack. So we always talk about it being the layer on top of everything else, where the BMS and EMS are much more responsible for immediate control of the system. Kind of raw data reporting. Analytics is really where you're doing a lot more advanced and automated correlation of that data. Being able to do more advanced sorts of state detection with larger data sets over time, and being able to learn in an automated way from that data. We also like to say it allows you to go from being reactive to proactive, and really be able to highlight issues before you know that they would be an issue. A few specifics on what can come out of that are shown here. So this is admittedly a lot of what we offer, but you're talking about system performance and availability. That's really everything in that left column there, where you're able to pinpoint imbalances long before you're getting any sort of voltage alerts or voltage spread alerts from the equipment. So you can stomp those out ahead of time and already start winning back energy. As Laura mentioned, warranty is a big topic. So being able to not only create these KPIs in an automated way, but also automatically track them over time to see if you're both operating the system within the expected envelope, but also that you're getting what you would expect out of the system. And then, a slew of other solutions that you can see here on the right in terms of, just getting high-level overviews of how the system or systems are performing, as well as some of the, some tools to be able to actually deep dive into those analytics outcomes. So in terms of working on FV3, this was quite a fun project for us. It actually is one of the first ones I ever worked on after joining TWAICE. But we kind of look at onboarding analytics in largely 3 chunks of work. So the first one is figuring out how we're going to get data from the system. Each system has different ways of, different types of data it's producing and different way it's getting logged. In this case, we're pulling data is being sent to us directly from the site, local historian run by the EMS partner. And in this case, we're in via CSV. We have many other options in terms of how we pull data via API or push the API and that sort of thing. But sometimes we go directly to the site. Then we have to figure out how we're going to map that data into a way that we can actually leverage it for analytics. So that's making sure that we actually have all the right tag points when we're doing things like state detection, like state of charge calculation. We need to make sure we have a certain subset of sensors that we can do that with. And then it also involves making sure that we understand what the overall topology of the site is. How many containers are actually feeding one PCS, or is there one container being split between multiple PCS, that sort of thing. And then we move into more of like training and analysis. So both training folks on how to use our analytics and on analytics in general, and through that learning together on what some of the quirks of the system are and what we can already start uncovering and remedying. So in terms of getting data, I always like to go through this. So when getting access to data is something that really should be discussed early on in projects, not necessarily the time of commissioning. So understanding how, what data is being stored, how it's being stored, who has access to it, and how can you access it. These are all questions that we go through with different projects. And the earlier that you can get these agreed upon, the better. In the case of FE3, I mentioned, everything's getting logged locally, and for us to get the data, it's getting packaged into CSV files and sent over. So that's a specific type of script that has to be run on site, and then from there we're able to ingest it and parse it for running our platform. Sometimes this is done via API, as I mentioned, and with all of these things, there's a slew of cybersecurity concerns and firewall settings and stuff that need to get sorted out. So earlier the better with trying to understand how you're going to access data. And then a little note on architecture. So with FE3, this was actually one of the first systems we onboarded that had a more of a modular architecture. Many systems we work with have more of a classic monolithic architecture where essentially it's just many strings or racks connected in parallel to one power conversion unit. And if any of those racks or strings have an issue, either at the cell level or module level, whether that's imbalances or a failure, it can actually take out all strings, all racks or strings connected in parallel. So that's where analytics really comes into benefit. Optimizing performance for availability and that sort of thing. But with FE3, they had actually a module isolated architecture. In this case, similar to string architecture, there's introduction of power electronics like DC converters to allow independent operation of either the string in a string isolated architecture or the module in a module isolated architecture. So in this case, actually, every module in FE3 is able to operate independently. So that does impact how we look at analytics and state detection on our side. So working through understanding that was really important. And I thought it would be nice to just highlight that here because we do see that a lot of people operating these systems don't have a full understanding of whether this has been implemented in their project or not. With that, I will hand it back over to Laura to talk a little bit about what sort of issues we uncovered during both commissioning and operation with analytics.
Yeah, here, I just want to highlight a couple of topics regarding the commissioning report. And one is that the test for the commissioning can be delayed. For example, in our case, we had some low solar resource days, so we were not able to do a full cycle of charge and discharge of the batteries. And also, we needed to respect central dispatch times and needs, so it also delayed some weeks the report. And also, and the most important thing for us, it was that this report helped us to do a claim to the manufacturer. Since you can see here in the image, we detected some misperformance, and they replaced the defective modules. And without this tool, we wouldn't have been able to detect that. And Matt can give us more details.
Yeah, just really quickly, we offer digital commissioning as a service, but really where this becomes important is uncovering a lot of these issues that wouldn't normally be seen in raw data. So track a number of KPIs around capacity and round trip efficiency and DC resistance. We've talked about this study in other webinars, but APRI has found that most of equipment issues that we see are introduced during commissioning. So it's important to have a closer look at the data at this time. And then Laura also alluded to some of the stuff that we found with Performance Manager. Even though the system they operated is more modular, we're still able to detect issues around voltage imbalance and SOC imbalance even at the module level. And we were able to remedy a few of those issues early on from the Performance Manager testing. analysis, auto performance manager, and commissioning report testing. And Laura's going to talk a little bit more about warranty as well.
Yeah. Again, this helped us to understand and be able to track the values related to the contract. First of all, and I think the most important for everyone, it was the performance warranty. Here you can see the state of health calculations and the full equivalent cycles calculation that we have on the website. And you can see that all the state of health are over 100%, except one that we had issues with, and that the full cycles are much lower than the expected ones. And this, of course, resulted in a lower degradation and lower equivalent full cycles. So we detected that we were not using the total BESS capacity, and this helped us to optimize the dispatch procedures and perform full charge and discharge of the batteries. You can also see here the graphic of the availability warranty that we get from the site, and only to do a brief introduction to the round-trip efficiency. I think it's very important to clarify that which round-trip efficiency values are included in the warranty, since one thing is the round-trip efficiency of the batteries and another one is the whole system. And here you can see a little bit some estimated numbers.
Thanks, Laura. Yeah, I think one of the important things to highlight with what Laura just mentioned is it's not only tracking the system to make sure that you're getting what you expect out of it, but it's also tracking the system to make sure that you're operating within the envelope that is going to be allowed the warranty and LTSAs to be enforced. So well, that's what we try to offer with our warranty solution. But a lot of these KPIs are generated as the system operates, and it oftentimes we see as like kind of the first indication that you need to dig deeper into a potential issue with the system, or kick off a more specified set of tests to see if the system is still meeting everything that was promised in the warranties. So we're always trying to come up with new KPIs and meet new LTSA language to do so. And then wrapping it up here, just wanted to talk, kind of to summarize our relationship through this project. So, first onboarding FE3, we were able to uncover a number of issues, both with analytics and without, but then apply to the insights learned from analytics to actually, understand what the root cause of issues were, and resolve them, both amongst us and with InterEnergy's partners. And I think through this process, we both learned quite a bit, both on the data side and operations side. And we do have a number of projects planned going forward. And I can personally say it's been a real pleasure working with Laura through this project. And I think with that, Laura, unless there's anything else you want to jump in with, we'll open up to questions.
Yeah, thank you, Matt.
Okay. All right, thanks very much. Yeah, great evidence of teamwork, I think, from you guys, both in the project and in today's presentation. So great to see. And we have had many questions coming in while you were speaking. We're only going to be able to scratch the surface of these. I will say that quite a lot of the questions refer to quite detailed design decisions around your project, Laura, which I don't think we're going to have time to get into, but I guess maybe if we can talk about some of the principles involved and so on. So a question here from Guillermo to kick us off. So thank you very much, Guillermo. Which KPIs or key performance indicators do you use to monitor battery storage system performance? And I'll say before I throw the question to our speakers, you're in luck, Guillermo, because in fact, some of Matt's colleagues at TWAICE worked with us on a webinar on this very topic. So you can find that on the on-demand section of ESN. That was broadcast in May. That said, handing over to Matt and Laura for your views on, the sort of KPIs you use to monitor performance overall once it's in operation.
Sure, I guess I can take this first. I think there's a number of categories of KPIs that we monitor for this. First one being what we mentioned with Performance Manager, where we're really recalculating in some sense the state of the battery for understanding how much usable energy there is, and then looking at the recoverable energy and actually breaking that down into reasons why the energy is recoverable. This is separate of battery actual cell aging. These are things like imbalances, highlighting offline equipment, looking for specifics within those imbalances of, if there's a cell voltages diving and stuff like that. So that's kind of one area of KPIs that we offer and monitor for that. We also look at more like trend and anomaly detection with certain sensor data. So when it comes to highlighting a potential issue with like a over voltage or under voltage or temperature issue in the future, oftentimes the equipment will detect this and either maybe give a warning, but oftentimes immediately shut down. So analytics can be used to track a lot of those specific sensor KPIs to highlight if they are, let's say, trending in an area where we think they're going to eventually cause a problem. And then the last category is kind of everything we offer in our warranty solution. So I think a good example of this is like a live round trip efficiency calculation. This is something that normally you have to carry out explicit testing for, but we're actually able to look at what the efficiency of all the power conversion electronics is while the system is operating, such that we can at least highlight potential issues if there's spikes in round trip efficiency anywhere, that sort of thing. I don't know if there's anything else you want to add, Laura.
Yeah, I just wanted to add that all this data that Matt treats, it's usually translated into state of health, depth of discharge, and equivalent cycles in the contracts.
Absolutely, and I think that brings us on nicely to, well, there are a couple of questions about battery storage offtake agreements and contracts. So let's start with this one from Maita. I hope I've got your name right there, Maita. Thank you so much for your question. So how do you couple uncertainty in battery storage performance with terms in offtake agreements? So I guess that's really around how you mitigate any margins for uncertainty in battery storage performance with the terms in the contracts that you sign. And I guess, Laura, if you could start on that from like a project owner point of view, and then maybe Matt, if there's something to be said in terms of how analytics can sort of mitigate those risks, that would be terrific.
Yes, actually, that was one of our first concerns when signing a contract. Since, of course, in the performance agreements or the warranty agreement, you have some stated values. No, for example, they fix you maximum depth of discharge. They fix you a maximum one equivalent cycle per day, and a degradation, no, that it's related to that, and related to the degradation is the usable energy you have at the point of interconnection. So of course, with all these inputs, they give you some performance numbers, and what we did with TWAICE, it was including all these inputs to the platform so they can calculate the real versus these targeted performance values. And of course, there's always uncertainty. For example, we had some data loss that at some points make us more difficult to calculate the real values. But I think it gives us a great overview and a great number of how the equipment is performing. Matt, if you want to add something.
Yeah, I mean, I think this is something that we continue to dive more into on our side, but it's, for example, we try to, in an automated way, highlight what the usable and safe envelope of the system is. So when you're dealing with things like unexpected derating or sudden loss of energy during operations, it's not just hey, this happened. This is we think this might not be operating as expected. Analytics can come in and kind of give that objective third-party perspective of, this is actually happening. This is, we believe, why it's happening. So this is something that we actually do with a feature called penalty risk, where we're actually able to highlight or actually recommend what the safe operating envelope is based on things like SOC errors in the system.
Okay, excellent. And we've got a couple of questions here. I think folks may be a bit less familiar with analytics, kind of asking a few questions. So I don't know if I can throw all of these to you, because ultimately, I guess their question is, what exactly is data analytics, maybe from this point of view. But Oksana asks if O&M providers can use TWAICE solutions, or is it only for battery storage system owners? And Jake asks if TWAICE performs the role of an optimizer. And we also have another question from Marcel asking if TWAICE's analytics is applied only for commissioning, or if it applies during operation. So a little bit, I guess some of the audience could do with a little bit of clarity in terms of where analytics steps in, and sort of what the role really entails from the beginning of the project's life cycle through operation. Matt?
Sure. Yeah, I mean, we try to come in as early as possible, because then we are getting basically a good handle on how the site or project is operating early on, and we can help with many commission related things, which is what we talked about here. But I would say most of our projects are with ongoing monitoring. We're not necessarily considered to be an optimizer in this case. We are much more focused on the lower level technical operation of the BESS system, ranging from the batteries themselves to power conversion electronics and that sort of thing. We really try to essentially make a digital twin of what the site is doing, such that we can peer behind the curtain a little bit from a data perspective to understand why certain behavior might be happening, and try to pinpoint exactly what could be causing it. In terms of who's using analytics, I think originally we really focused on higher level insights for owners, operators, but as we've progressed, I think we're spending more and more time on providing tools for battery performance engineers and O&M teams. I'd say a lot, like our last few projects, especially in North America, we've been directly working with O&M teams on how they can leverage analytics in our platform to gain insights. I think this is where there's some overlap with EMS and analytics, but EMS tools will maybe give you the ability to look at time series data, maybe an alert or alarm map, but it really is analytics is kind of complementary to that, where you're able to kind of use EMS for the instantaneous day-to-day work, but then rely on analytics for understanding what could be addressed in a more proactive fashion. So I think in terms of what can O&M teams benefit, my personal stance is definitely yes, because actually my previous background at TWAICE was more on the O&M sort of side of things, and I think these tools give a lot more transparency than what you can normally get just from kind of EMS data.
Excellent. And Laura, I don't know if I can ask this, but what would it be like to now develop a battery storage project without analytics? Do you think it's something that you could do without, or is it just a lot more complicated, or how does that kind of smooth out the process for you?
Yeah, and developing and constructing, you can do it, of course, because you still don't need data. And related to the previous question, TWAICE, it's not like a real-time data. For that, we have the SCADA and the PPC, and we could operate with that. But I think we would lose granularity of data and analytics of this data, because of course we can get the data from SCADA and treat the data, but that's what TWAICE does it in a much more detailed and much more tools that we could have. So my opinion is that we could have done it, yes, but without half of the information that we are having from the batteries, and we won't have that detailed level information.
Absolutely, absolutely. So I think, we've run a little bit over time, because, that's what happens when we're having a really good discussion, I think, sometimes. If you guys are okay to do a couple more quick questions, we'll do a couple more, and then we will have to call time for today. And then, having said that, I've lost the question. Yeah, so sorry, Laura, there were like a few questions, in fact, on kind of the project design and some of the decisions you made. Definitely haven't got time for all of them, and some of them are a little bit too detailed and will probably, would lead to a very detailed technical discussion that not everyone will have time for, unfortunately. But there was a question early on that I thought was interesting. So Norberto, thank you for your question, was asking specifically which distance you used between the placing of the containers on site, but also if you followed any standard. And if I may, could we just broaden that question out a little bit, like in terms of building that first project, how much were you able to lean on things you learned from like other people's experiences, and how much was dictated by perhaps the standards that were in place? So someone else asked about the grid codes and like utility requirements. Like how much of that kind of came to you from things you were able to lean on, and like how much of the design was really like, learning step by step as you did it?
Yeah, I think that it's been a joint work together with the manufacturer. And for example, related to the layout, you have manufacturer specifications, but you have, for example, insurance specifications that are different, and you need to have all in account. And again, with, for example, grid requirements, it's also a joint work together with other grids and the knowledge of other countries. And as I said, also, we are still learning. So, of course, this project was like the development was slower than the following ones, and of course we have improved in a lot of topics. But I think like it is really important to work together with everyone involved in the project, and yeah, do as much as possible together, and yeah, just throw questions and have joint sessions.
Excellent. Yeah, it sounds like a really collaborative and pretty exciting process, I think. So yeah, so last question, and it is quite an important one, I think, from Roll. So thank you for your question, Roll. So asking if the analytics solutions are able to detect data inconsistency and help you solve that. So, or does it apply to the concept garbage in, garbage out, which people often say about feeding, AI in particular, and then you somehow need to find why results are bad. So I guess this is really getting to the point of how does TWAICE collect the data and make sure it's the clean, the kind of data you actually need to use, I guess.
Sure. Yeah. I guess there's a number of byproducts or benefits that come with onboarding analytics beyond just the actual insights in that sense. I know Laura can talk quite a bit about the number of data issues we did encounter with FE3, largely around outages and trying to track down where those outages, why those outages were happening. But there's a whole number of other sort of tools we have in place to ensure that the data that's coming in is not going to be garbage in, whether that's just applying general, more like cleansing rules to make sure that the sensor data is making sense, kind of throwing out outliers or flagging outliers. But then we also have a number of detections around, how do we deal with on-change data that maybe only sends a new data point when the sensor is actually active versus periodic where it's sending continuously. We have to deal with making sense of that data and making sure it's accurate. Another example is stale data when there's a ECU lockup and basically the same value keeps coming out of the Modbus register. We have methods in place to detect when that's happening and ensure that the data coming in, at least it's feeding our algorithms, is going to be accurate, and then also flagging that to our customers to make sure that they are aware this is happening and can take steps to fix it.
Excellent. Okie dokie, folks. Thank you so much for your time. Thanks firstly to Matt and Laura. Thank you very much for your presentations. And yeah, it's been really, we've done quite a few webinars now with TWAICE, and delighted to have done so. And it's, yeah, always bringing some interesting angle, I think. And this is particularly, I think, in terms of things the audience can relate to and just find interesting, I think. It was another good example. So with that, thanks a lot to our speakers. Thanks, of course, for TWAICE for working with us on sponsorship level. And thank you, Laura, to you and InterEnergy for agreeing to take part as well. It's been really useful. Most of all, though, of course, thank you so much to the audience who registered and taken time out of their precious time out of their working day to join us for this. And yeah, I want to thank you not only for that, for all the hard work you do in making this vibrant industry and an important part of the energy transition an everyday reality. So thank you so much for that, and we look forward to seeing you next time. Bye for now.